Okay. Hello. Welcome to Chemical and Physical Changes STEM case. So to start, you're going to click when ready. I'm going to walk you through the background for this activity. So, you were a forensic scientist working in a Secret Service laboratory. The Secret Service was established in 1865, and it wants you to know that if you click on terms, it will take you to the glossary and it will define the word for you. So, a forensic scientist are scientists who use evidence to find out what happened in a crime. And today, you are going to act like a forensic scientist. It investigates the counterfeiting, faking of United States money. So, you are a forensic scientist working in the Secret Service laboratory. Last week, Secret Service agents got a tip about a criminal group. These criminals were making fake gold coins. And I can just press this video, but you can see FBI agents walking around. Okay, I'm going to go to evidence one. So the Secret Service found coins that looked like $50 gold coins from the year 1915. If the coins were real, they would be worth $25,000 each. They also found copper and silver coins that looked like gold coins. They were blank copper coins and chemicals. They also found a machine that can make coins look like the 1915 coins. The gold coins were cut in half. The inside of the coins were copper, not gold. This means the gold coins are fake. The suspects may have changed copper coins to look silver, then changed the silver-looking coins to look gold. As a forensic scientist, your job is to find out how the suspects made the fake coins. You need to research the properties of matter for your investigation. So I'm going to click the handbook to learn more. Welcome to the Chemical and Physical Changes Handbook. I'm going to use the arrows to move through the pages, and I'm going to begin. So the suspects changed the matter of the coins to make them look silver and gold. So they started with copper, they made a silver-colored coin and a gold-colored coin. What is matter? Matter is anything that has mass and takes up space. The child, bike, air, and the bike tires and street are all made of matter. The sunlight is not matter because it does not have weight or take up space. So we are going to choose all the examples below that are made of matter. So heat, its mass is 0 grams. Plant has a mass of 100 grams, and a rock has a mass of 500 grams. In our definition of matter, we know heat cannot be made of matter. So we're going to click on the plant and the rock. So yeah, heat does not have mass or take up space, so it is not matter. But both plants and rocks have mass and take up space, so they are matter. What is matter made of? All matter is made of tiny particles that are too small to see. The tiny particles in matter are called atoms. Atoms are the smallest unit of matter. I'm going to click this box to zoom in to see the atoms. Atoms are too tiny to see. Let's learn about atoms. There are over 100 different atoms. Different atoms are called elements. These are found in the periodic table of elements. Let's take a closer look at oxygen. Oxygen is the 8th element, which is represented by the letter O. The matter we see is made of atoms that are joined together. Atoms join together to make molecules. So here are two lonely atoms. Let's make a molecule. We've just made a molecule by adding a bond. So atoms are held together by bonds. Same elements. Some molecules are made of the same element. An aluminum lid is made of many aluminum atoms bonded together. The air in the speaker has oxygen molecules that are made of two oxygen atoms. Different elements. Some molecules are made of different elements. Salt has sodium and chlorine atoms. The atoms are organized in a repeating pattern. So the sodium atoms are represented by these purple balls, and the chlorine atoms are represented by these green balls. Water has hydrogen and oxygen atoms. Oxygen is going to be red, and the hydrogen balls are connected to that oxygen with two bonds. The patterns in matter are made by the bonds between atoms and molecules. The patterns of atoms and molecules give matter its structure. Different structures have different properties. Diamond structure, the structure of a diamond is stiff, so atoms cannot move. This is why diamonds are the hardest substance on Earth. Rubber structure. The structure in a rubber band is very loose, so the atoms can move. This is why rubber bands can stretch and bend. So as you see in this graphic, as he's pulling the rubber bands, you can see the bonds and the actual molecules itself are stretching as well. The atoms and molecules in matter create the properties of matter. Properties of matter are traits that can be observed or seen. There are two main properties of matter: physical properties and chemical properties. Let's start with physical properties. Examples of physical properties are color, temperature, hardness, and mass. So, the physical properties of tin. Its color is silver gray. So we could say the tin bar has a silvery gray color. The hardness is high. The tin bar is hard. It does not bend easily. Temperature, 25 degrees Celsius. The tin bar is at room temperature. Its mass is 1 kilogram. This tin bar has a mass of 1 kilogram. When physical properties change, it is called a physical change. Physical changes happen when matter changes. When a blacksmith shape metal, they heat the metal first to make it softer. So let's play this clip and watch. Okay, he's shaping the metal as it's being heated, so he can mold it into the shape that he would like. Changing the temperature of matter can also change its state. For example, if you make water cold enough, it becomes ice. So let's make the water cold. No. Okay, it has now become ice. As you cool the water, the molecules move slower. The slower molecules stick together to make solid ice. So it's in a liquid state. As it's going to ice, it becomes solid, and the molecules are moving slower. Water is a liquid and ice is a solid. Cooling water changed its state from a liquid to a solid. Important fact: big changes in temperature can have a big effect on the state of matter. Temperature changes the state of matter. If you lower the temperature of a gas, it becomes a liquid. If you lower the temperature of a liquid, it becomes a solid. If you raise the temperature of a solid, it becomes a liquid. If you raise the temperature of a liquid, it becomes a gas. So these are all like interconnected states of matter with temperature changes. Cooling makes molecules move more slowly. Molecules that move slower bump into each other less. This means the molecules stay closer together. Let's zoom in to see the gas molecules up close. Okay? As we're looking at the molecules up close in the gas, they're moving pretty fast. They're bumping into each other a lot. Let's look at the liquid molecules up close. Okay, you can start to see that the molecules in the liquid are still bumping into each other, but they're a lot closer together compared to the gas. Let's zoom in to see the solid molecules up close. Whoa, the solid molecules are densely packed together and they're barely bumping into each other compared to the liquid and the gas. The gas molecules move slower and get closer to becoming liquid. The liquid molecules move even slower and get even closer to make a solid. The solid molecules move quicker and spread out to become a liquid. The liquid molecules move quicker and spread out even more to become a gas. So let's drag and drop the states of matter in the correct order. So slower molecules are going to be on the left, and faster molecules are going to be on the right. So when we were zooming in to look at the molecule speeds, we saw that the solid had the slowest molecules, whereas the gas had the fastest molecules, and the liquid was in between. So let's submit and correct. Gases move the fastest, liquids move slower than gases, and solids move the slowest. Okay, we have names for the states changes: condensing, freezing, melting, and boiling. Gas, when changed to a liquid, is condensing. Gases condense to become liquid. Liquids can freeze to become a solid. So liquid to solid is called freezing. Solid to liquid is called melting. Solids can melt to become liquid. Liquid to gas is called boiling. Liquids can boil to become gas. Drag and drop the correct state of matter with each picture. So we have our solid with our densely packed molecules. We have our gas with our molecules that are bumping into each other a lot and they're super spread out. And then our liquid is always going to be in between our two extremes. Let's submit to check. Correct. Gases molecules are the farthest apart. Liquid molecules are closer than gases. Solid molecules are the closest. Another physical change is mixing. Mixing has a big effect on physical properties. Let's say you spill a glass of water and wipe it up with a paper towel. This makes a wet paper towel. That is a physical change. Let's watch to see what happens. So we now have a physical change with the water spilled on the paper towel. It looks darker than a dry towel. The wet paper towel is also easier to tear. The physical properties have changed. This means mixing caused a physical change. Another example of a mixture is making a solution. A solution is made by dissolving one type of matter into another. Sugar is a solid. Water is a liquid. When you mix sugar into water, the sugar dissolves into the water and makes a solution. The sugar solution has properties of both sugar and water. The sugar solution tastes like sugar. Just like water, the sugar solution is a liquid. It is also clear like water. If you mix solid metals, you can make alloys. The color changes when the metals are mixed. So the solid metal of copper with tin makes the alloy of bronze. Mixing the metals tin and copper make bronze. Bronze is harder than tin or copper. The color is a mix of copper and tin colors. Let's zoom in to see the atoms. First, let's start with copper. We can see the atoms are packed tightly together. This is a solid metal. Let's look at tin. Tin is similar. Now let's look at bronze. This is what they look like when they mix. Okay, you see both the copper atoms and the tin atoms mixed together to make bronze. Copper plus tin equal bronze. If we added more tin than copper, what do you think the color of the bronze would be? Choose the correct color for this mixture. So, if we're adding more tin than copper, the color would most likely be lighter, like tin. I don't believe it would get darker. Let's check. That is correct. So adding more tin makes bronze look more tin color. The atoms and molecules in matter create the properties of matter. Properties of matter are traits that can be observed, which are seen. There are two main properties of matter. Let's learn about chemical properties. A chemical property is any property of matter that changes the bonds of a molecule. Flammable, toxic, and corrosive are examples of chemical properties. Physical properties, like we talked about earlier, are color, temperature, and mass. But we're going to focus on chemical properties. Chemical properties are types of chemical reactions that matter can have. Chemical reactions change the bonds in matter. If you pour a corrosive liquid onto a metal, a chemical reaction happens. The chemical reaction breaks the bonds between the metal atoms. Let's watch. Okay, we're adding that corrosive liquid and watch what happens to the metal. Wow, that is pretty cool. In class, we cannot use a corrosive liquid like this. Okay, so you have your corrosive atoms and then the metal atoms. The molecules in this reaction break and form new bonds. Let's press play. Okay, so you notice that the corrosive atoms are now making new bonds with the metal atoms, which for our eyes results in a new appearance, right? This changed. It doesn't look the same. Let's take a closer look at chemical reactions. The things that react are called reactants. The things made from a reaction are called products. Reactants. There are two hydrogens in this molecule. The hydrogens are represented by these white balls. There are two oxygens in this molecule. The oxygens are represented by these red balls. There are two molecules and four atoms in the reactants. So each ball is one atom. When they're combined by a bond, this is a molecule, which is why there are two molecules present and four atoms. Let's look at the products. The product is now two hydrogens and two oxygens in one molecule. So the two molecules join to make one molecule, but they're still four atoms. Matter is conserved in reactions. This means that there are the same number of atoms in both the reactants and the products. How many molecules of nitrogen and hydrogen are needed to make a molecule of hydrazine? So here's hydrazine, and we need to find how many molecules of nitrogen and how many molecules of hydrogen are needed to make this. So let's count to see how many atoms of nitrogen, which is represented by these blue balls. So we have two atoms of nitrogen. So my only option down below that seems to make sense is this middle option, since there's 2 atoms of nitrogen and 4 atoms of hydrogen, which I can see up above. Okay, so I'm going to click this and hit submit. So there are 4 atoms of hydrogen and 2 atoms of nitrogen and hydrazine, NH4. That means you need 2 molecules of hydrogen, H2, and 1 molecule of nitrogen, N2, to make hydrazine. Okay, so we have now completed the chemical and physical changes handbook. Let's find out how the suspects made the fake gold coins.